So in this video, we're going to talk about topic 2.2, and this is the explain to, and we're going to be looking at example 2, probably parts A and B, and then we'll do the last little bit in the last part. I totally missed this part here. I'm sorry, this isn't writing very well because I'm in a different program. In this part here, I'll try with the highlighter, with the mouse. Maybe highlighter, let's see if that highlights. No, it doesn't want to. Nope. So anyways, this part here, this paragraph isn't in the notes, so we're going to read through it together. And I apologize that it got left out. When given a set of paired data, you can use a scatter plot to see whether the data show a linear trend. This is what we were doing in task 2 with the colleges in unit 1. So this will hopefully help you reinforce that if you didn't completely understand it. So if you can use a graphing calculator to perform a linear regression and obtain a linear function that models data, you should treat the least and greatest x values of the data as the boundaries of the domain of the linear model. When you perform linear regression, a graphing calculator will report the value of the correlation coefficient R. We talked about the R squared value when we were doing it before. This variable can have a value from -1 to 1. It measures the direction and the strength of the relationship between the variables x and y. If the value of R is negative, the y values tend to decrease as the x values increase. If the value of R is positive, the y values tend to increase as the x values increase. The more linear relationship between x and y is, the closer the value of R is to -1 or 1, the closer the value of R squared is to 1. So that was the whole, we did all of that when we did the task in unit 1. You can use the linear model to make predictions and decisions based on the data. Making a prediction within the domain of a linear model is called an interpolation. So within the linear model is an interpolation. Making it outside the domain is called an extrapolation. So what we did in our task was an extrapolation. All right, I'm going to come back over here, and we're going to look at example 2. So a photographer hiked through the Grand Canyon. Each day she stored photos on a memory card for her digital camera. When she returned from the trip, she deleted some photos from each memory card, saving only the best. The table shows the number of photos she kept from all those stored on each memory card. Using a graphing calculator, create a scatter plot of the data, find the linear regression model, and graph the model. Then use the model to predict the number of photos the photographer will keep if she takes 150 photos. All right, so we're going to go through all of these steps. We're going to perform linear regression, write the model, graph the model, predict the number of photos. So we're going to do that, but we're going to do it within Desmos, and I'm going to take you from step 1 in Desmos all the way through this. So you're going to hit the plus sign. We're going to hit a table, and we're going to type in the numbers. So it was 117. I'm going to go down my X column first, 128. 140, and notice it's trying to predict a little bit. After the third one, it doesn't predict anymore. 157, 110, 188, and 170. I'm going to go back up to the top again because that's just what makes sense to me. 25, 31, 39, 52. I'm just hitting enter after each one of these. 21, 45, and 42. And then what I'm going to do is I notice that I don't see my plots on here. That's because I don't have the domain that the function needs. Look at this. These are all in the hundreds. I don't have that kind of domain, and I definitely don't have this kind of range either. So I'm going to go to the wrench, and I'm going to reset my scale here. So I'm going to take X from maybe 0 to maybe 200. And then I'm going to take Y from maybe, let's say 0. I don't have to include 0. I'm just choosing to do that to 50. And you'll notice that some points, we picked up some points. Maybe I want to go a little bit beyond 200 because of it running into the wrench here. So maybe I'm going to say that it is 250, just so I can get a better picture. There we go. So we've got all of our data points right in there. So then what you're going to do with this little guy highlighted, you're going to hit the plus sign again. And you're going to go expression. Oops, I want this to be above it. So I'm going to drag it above it. And then I'm going to write the equation. I know I want a linear regression, and I'm because that's what we're doing right now. So we're going to do a linear regression. It's a little different than using the spreadsheet or your graphing calculator. I'm going to go y, and then I'm going to use the tilde sign, which is right next to the 1, and you have to hold the shift key down. So it's right there, okay? And then I am going to do m, and then for slope, x. Oh, I forgot something on the y. I was supposed to put a sub 1. So you hold the shift key down, and then next to the 0, the underscore 1. Let me do the same thing with the x. Shift, hold the underscore down 1, and then plus b. And you'll notice some things popped up in here. We've got our correlation coefficients that tell us how good this is. So we know we're at about 71, which isn't great because look, it's not touching much of the data, but it's okay. And then look at this. This is the equation of our line. So if we were going to write the equation of our line, we would write y equals 0.33097 x plus, or actually minus 11.3257. Okay. Now, I'm going to go ahead and write that in our notes and record that for us. So we know that we did a visual check. We're going to write the linear model. So y equals, we said it was, I got to look, 0.33. I'm going to go a little bit more decimal places than the book does. 0.97. This is my calculus teacher coming out here. Minus 11.3257. All right, so we've graphed the model, we've visually checked it, so we've done step 3. We're going to now predict how many will be 150 photos. So we would say y equals 0.33097, and then 150 minus the 11.3257. Well, those are some ugly numbers, so let's use decimals to do that for us. So all I'm going to do is I'm going to type in this 0.33097 parentheses 150 minus 11.3257, and then there's my prediction. It's 38.3198. So 38.3198. Okay, so let's interpret what that means, okay? So what that means is that she will take about 38 photos for every, she will keep about 38 photos for every 150 she takes. Ooh, that was not what I wanted. Okay, she will keep 38 photos for every 150, that's 150 she takes. All right, let's try B together. So as a science project, Shelley is studying the relationship of car mileage in miles per gallon and speed in miles per hour. The table shows the data Shelley gathered using her family's vehicle. Use a graphing calculator to create a scatter plot of the data, find a linear regression model, and graph the model. Then use the model to predict the gas mileage of the car at the speed of 20 miles per hour. So first of all, it's asking us what do the X and the Y represent. So X is the car's speed. And then Y is the gas mileage. And if you're confused about that, this is the X column, right? And this is the Y column. What viewing window will I use? Well, if I look at my X's, so for my X's, I would probably go from 0 to maybe 80. So I get that whole domain in there. This is basically the domain. And then I'm probably going to go from 0 all the way to, I don't know, probably about 40 here. And then what trends do you observe? So let's actually go ahead and actually do this graphing. I already started the graph for us. So open graph. All right, so there's my graph there. I'm going to go ahead and do those settings. So we said we were going to go from 0 to about 80. And then here I'm going to go from 0 to, we said, about 40. And you'll notice that we've got our plots on there, okay? And it appears that our data looks like, just looking at the data, not doing anything else with it, it looks like they seem to be going in a line, and they look like they're decreasing. So they seem to be linear, and decreasing. Okay. Performed linear regression, write the model. We know it's going to be y equals something x plus something, right? Okay, so we're going to do our linear regression in here. So I'm going to click on this. I'm going to hit the plus, and I'm going to go expression. Hopefully it pops up above. So it's y, the tilde, oh, y, not the tilde yet. Shift, the underscore, sub 1. Now the tilde, mx, shift underscore, sub 1. And then plus b. There's our line. So we know we've got our slope is negative 0.175 and our y-intercept is 39.85. So let's go ahead and write our equation. So y equals, I totally forgot it already, negative 0.175. That's a point. And then it was 39.85. Okay, now we're supposed to get a visual check. So I'm going to actually write that. I'm going to try to check that out. Y equals negative 0.175x and then plus 39.85. Looks like we've got it. And you'll notice our correlation coefficient's pretty good, right? We're really, really close to 1. So that's a good thing. That means a really good model of our data there. All right. Now that we've checked that, we need to actually predict. Let's see, what did it want us to predict? 20 miles per hour. So we're going to basically plug a 20 into that equation. If I was going to show my work, I would say negative 0.175 times 20 plus 39.85. And let's go ahead and use Desmos to do our work for us. So we've got negative 0.175 times 20 plus 39.85. So 36.35. Okay, and then what does that mean? So that means that the car's gas mileage is 36.35 miles per gallon at 20 miles per hour. It's possible the book does some different rounding with this there, because I'm looking at the book answer and they rounded it to 0.4. All right, so we're supposed to really quickly identify whether they're interpolations or extrapolations. So interpolation, remember, it happens in the domain, whereas extrapolation is outside the domain. So if I go back up here to this first one, it's asking about 150. And notice 150 is inside these numbers that we had. So that would be an interpolation. Whereas they said 20. Really, our domain in here did not include the 20, so that would be an extrapolation because 20 would have been somewhere before this. So we would say that A was an interpolation and B was an extrapolation. You might want to write the note that that's because this was inside the data and this one is outside the data. Data set.